In 1936, a young German engineer had a dream. A machine that could do calculations automatically, without the need for human error. After asking his parents for cash, toiling away at home for 2 years, he achieved the impossible. He created the world's first computer, and he did it with no knowledge of the world's leading mathematical figures. This is the story of the remarkable Konrad Zuse. Konrad Zuse was born in Berlin in 1910. The son of a postal clerk, he had a keen interest in mechanics from a young age, constructing a coin-operated Mandarin vending machine at age 14. He went to study mechanical engineering at Technical University Berlin-Charlottenburg by 17, but quickly switched from architecture to civil engineering. Set up with a comfortable and promising career at Henschel Flugzeugwerk, Zuse did something quite odd. He quit. Enthusiastically went to his parents and asked if he could have funding to create an automated computing machine. After winning over his parents, Zuse set to work. Zuse's original idea was for a machine that could be programmed to solve different mathematical problems. This would reduce the amount of monotonous calculations engineers would need to do to solve problems. Zuse's Z1 was not as complex as machines theorized by Turing, Church and others, but it was real, practical and, most importantly, working proof that such a device could exist. What was remarkable about the Z1 was its similarity to modern CPUs. The machine had a control unit, which broke down instructions for the computer to use, an arithmetic unit, which performed calculations, a bus, which could be used for data transfer, and finally, a memory unit, which could be used to store calculation values. The Z1 read instructions from a punched tape, each punched hole representing a different input value. This was fed into the computer, which, similar to a modern CPU, had various operation codes. This allowed the computer to perform different operations. In this case, Z1 could perform addition, subtraction, multiplication, and division. All of this was done by mechanical means, with no electrical circuitry. Zuse worked tirelessly to make his machine, using a fret saw to cut his metal components. The design was elegant, using layers of sheets and rods to create binary calculations, set memory, and transport information from one part of the machine to another. The machine itself was an impressive physical creation, weighing almost a ton. Zuse originally intended for calculations to be driven by a hand crank, but it soon became clear that an electric motor was needed to drive calculations. By 1938, Zuse had completed his creation. The Z1 saw its first uses, but it would only be a year later that history would intervene. Germany invaded Poland in 1939, and the Second World War would begin. In the late 1930s, there were a number of contemporaries who were working on similar concepts to Zuse. British computer scientist Alan Turing, who created the modern idea of a computer while studying at Cambridge University. Turing's idea was called a universal machine. Turing's machine could be programmed using magnetic tape, with a set of instructions which could be read by a machine. The machine would then use the information stored on the tape to implement a set of instructions on a computer. What made the universal machine special was its ability to recreate an entire Turing machine within the machine itself. In other words, a machine could be simulated within a machine. For similarity, we can compare the Z1 to a Turing machine. As in Turing's described machine, information is read in by tape and is used to perform instructions. While the Z1 can perform instructions, it is unable to simulate a version of itself, and therefore not a true Turing machine. While more theoretical than practical at this stage, Turing's work would go on to inspire most modern computing systems, and the work of John von Neumann in America. His computing machines would help the UK break the German Enigma code in the early 1940s. Turing wasn't alone in his ideas, however. The brilliant mathematician Alonzo Church was responsible for creating what is known as lambda calculus, a set of mathematical rules which formed the basis of theoretical computer science. We'll be talking more about Turing and Church in another video. Zuse was highly intelligent and driven, using his intelligence to his advantage by convincing the German military to fund his new computing machines, the Z2 and Z3. He started a computer company, Zuse Apparatbau, to manufacture his computing machines during the war. Unfortunately, tragedy struck for Zuse and his creations. British air raids destroyed his workshop in 1941, and in 1942 his parents' flat was bombed, destroying the original Z1. In 1942, Zuse began work on a new computer, the Z4, which would be an improved version of the Z3. By 1945, bombing raids had made work in Berlin difficult, and the Z4 was moved twice, to Göttingen in February, and finally Hinterstein. Zuse hid the Z4 from the world in a stable, as the Second World War came to an end.
That's why these children are practicing to duck and cover. The atomic bomb is very dangerous.
With the wartime destruction of the German economy, Zuse was unable to work on his creation, and instead spent his time doing something quite remarkable. He began to create a language which could be used to manipulate computers. The world's first programming language, Klangkalkul. Once again, Zuse did this in complete isolation, with practically no influence from the outside world. It was in 1949 that Zuse managed to show the Swiss mathematician Eduard Stiefel the ability of the Z4 to calculate a differential equation. The Z4 was purchased for the newly created Institute for Applied Mathematics in Zurich. It was the second computer in the world to be sold, beaten only by the American Binac computer. Zuse went on to create a new company in 1949, Zuse KG, to restore the Z4, and went on to become Germany's leading computer manufacturer in the 1950s. The company produced more than 250 computers from 1949 up until 1969, where it was eventually sold to Siemens. Zuse continued to be an original thinker, creating inventions such as vector plotting printers. He wrote a book, Reckende Raum, or Calculating Space, that set out a novel idea that all processes in the world are computational. This is the basis for modern simulation theory. Zuse was a pioneer and a highly practical man, but he wasn't the first to attempt to build a computing machine. Join us next time as we travel further back in time to look at the world's first computer engineer, Charles Babbage, and the world's first programmer, Ada Lovelace. For those interested in more Z1 content, YouTuber Michael Holzu has an excellent breakdown of the mechanical workings of the computer, which can be found in the annotation. The Ghostwriting AI project is a small project using artificial intelligence and machine learning to analyze stories and create new works of fiction. If you want to know more about us, please visit our channel or take a look at our website. Thank you for watching.